Continuing on with our quadratic world, and we're talking about the imaginary unit. So when we solve a quadratic, whether we use factoring, solving by using square root methods, or using the quadratic formula, or graphing, which is probably the worst way to solve. But when we use one of those methods, we end up with two solutions, okay? Two solutions. That first one and that second one on the graph, both of these are images of real solutions. Both of these are images of real solutions. This one only has one solution, and this one has two. Now, some of you realize that because it's x squared, that squared value, x squared, that exponent tells you, because it's a quadratic, that you're going to have two solutions. You should always have two solutions. The reason this one only has one is because it's the factor x minus 3, the quantity squared, right? Or this would actually be x plus 1 is really what that is, the quantity squared. And remember, that just means that what are my two roots? Well, my two roots are both -1, right? Because it just bounces right on that. It just bounces right on the y, or on the x-axis. This is not a real solution. This is an imaginary solution. Yeah, go right ahead. This is an imaginary solution, and it's because it never touches the y of the x-axis. It never touches the x-axis, which is what a solution is, right? A solution is where it crosses the x-axis. So notice that this never touches the x-axis, never touches the x-axis. So today we are going to look at some powers of I and some complex numbers, okay? So we learned on Friday, the whole idea on Friday was that the square root of -1, we cannot take the square root of a negative number, because there is no number that you can multiply by itself and get a negative, right? So we said, well, the square root of -1 is I, and that I stands for the imaginary unit, okay? So if I wanted to think about taking the square root of -16, I can rewrite that as, break it up as a product, the square root of -1 times the square root of 16, but I know that the square root of -1 is I, and I know that the square root of 16 is 4, so this equals 4I. That was the whole idea behind your video on Friday. I want to remind you that you also learned about I squared, which is just I times I, which is the same thing as, well, what is I? The square root of -1 times the square root of -1. And what is the square root of -1 times the square root of -1? It's just, remember, like if I had rewritten this 16 as the square root of 4 times the square root of 4, because 16 is 4 times 4. But we said that the square root of 16 is what? It's 4. Notice that when you take a square root and you multiply it by itself, when you take a square root and you multiply it by itself, what happens to the radical? You're taking the square root of -1, and you're squaring it. This power of 2, which is something times itself, makes the square root symbol disappear. They cancel each other out. They're inverses, right? So you learned that the square root of -1, the quantity squared, or I squared, is just -1. So we're just going to work with I and I squared for these first few examples. We're going to work with I and I squared. Is everyone okay if I move up? Okay. So our first example is the square root of -9. Well, that's the same thing as saying the square root of -1 times the square root of 9. But I know that the square root of -1 is I. And the square root of 9 is what? 3. So this equals 3i. I is just like a variable. We know what the value of it is. We know that I stands for the square root of -1, but it's just like a variable term. So the whole numbers or the coefficients have to go in the front of it when we multiply them, right? So this next example has a plus or minus out in front of it. That means I want both the positive and the negative root. So let's see, the square root of -64. Well, that's the square root of -1 times the square root of 64. What is the square root of -1? Yeah, so plus or minus I times, what's the square root of 64? So my answer is the positive and the negative 8i. The positive and the negative 8i. So when I look at this next example, I just want the negative root. That's what that minus sign outside of it means. You're just going to give me the negative answer, right? So let's see. The square root of -49 is the same thing as the square root of -1 times the square root of 49. But what is the square root of -1? I. And what is the square root of 49? And I need to bring this negative out here. So when I multiply them all together, right? When I multiply them all together, I get -7i. Thoughts?
So it's basically just finding the square root of it and then kind of
Pulling an I out. Pull out an I. Yeah, that's exactly what it is. To get rid of the negative sign, you just pull out an I. Yep. Uh-huh. Because do you see this? That's why. That's a good question. So if there's just a square root symbol, like in the first example, you just are going to give the positive root. If there's a positive and negative out front of it, then I want both the positive and the negative root. If there's a negative out front, I just want the negative root, like in this example. The positive root is called the principal root, and that's the one that we typically use. Okay. I think there's one more example on this page. Oh, several more. Okay. So what about this one? So I'm going to go with what Chandler just said. If I have this negative underneath a radical, what are you really just doing? How do I get rid of that negative? Pull out a what? Pull out an I. Yeah, I'm just going to take an I out. So I have 2 times I times the square root of 7. Because remember, this is the same thing as the square root of -1 times the square. Well, it is. I mean, isn't -1 times -7 -7? So can't I just pull the I out and write it as this I times the square root of 7? Isn't that what we just did? So I'm wanting you guys to recognize that you can just pull an I out and have the positive number underneath the square root. Okay. Can we simplify the square root of 7? Anyone? No. Okay. So this next one, I have a negative out front. This right here, that's the square root of -1 times the square root of 13. But we know that the square root of -1 is what? I. And don't forget this negative you have out there, right? So I have negative I times the square root of 13. Can I simplify the square root of 13? No, I cannot. Nope, nope. Okay. What about this one? What is this telling me out front right here? Yeah, I want a positive and a negative answer. Let's see. 20 is the same thing. Negative 20, sorry, is the square root of negative 1. How can I break that 20 up with a perfect square? The product of a perfect square. Yeah, 4 and 5. Right? Let's see. We know that the square root of negative 1 is I, and the square root of 4 is 2, and we cannot simplify the square root of 5. I times 2 is 2i. So I have plus or minus 2i times the square root of 5. Does that make sense? Sir? Yeah, that's what I was trying to say earlier, but someone said they still need to see the negative 1. Yeah, when you see a negative, just pull an I out. Just like yank an I out because it's already there. Okay. So let's look at this one. So are you okay with me just pulling an I out? Do I not have, is it okay that I don't write times the square root of negative 1? So this is really 4 plus or minus I times the square root of 63. That's really what that is. Taking out that negative 1 square root is just like pulling out an I. That's really what we mean when we say that. But I still have to break up the square root of 63. Sir?
So basically, like you want to think of it as a simple way, you really just drop the negative into an I and write the square root.
That's exactly what you do. You pull that negative out from under the radical and make it an I on the outside. Yes. But we still have to rewrite 63 as a product of some two numbers. One of them should be a perfect square. So I know that I can simplify that. Yeah, good job. 9 and 7. So this one's going to look different than all of the other ones that we've done so far. What is the square root of 9? So I have 4 plus or minus I times 3 times the square root of 7. I have to figure out how to write this I times 3. Well, how should I write that? 3i, yeah. So it's 4 plus 3i times the square root of 7, or 4 minus 3i times the square root of 7. Or you could just write it as 4 plus or minus 3i, the square root of 7. So you either write it as two separate answers, right? Two separate answers, the plus and the minus, or just smash them together. It's your choice. Thoughts? You guys feel okay with that? Huh? Yeah. Aren't we on a you try next? Or not yet? Not yet. Okay. So I want to talk about the I squared, I cubed kind of thing. So this big idea right here, another big idea. What did we say I squared is? Well, it's negative the square. It's the square root of negative 1 times the square root of negative 1, which is what? What'd you say? Oh, yeah, it is I times I, but I is the square root of negative 1. What does that equal? I just did it on the front page. What did I say that equals? Say it again. Equals negative 1. It equals negative 1. So I squared is the same thing as negative 1. And I actually drew a circle for you guys on Friday. So I'm going to try and just draw this little sketch up here of what I had on the board. This is I to the first power. This is I to the second power. This is I to the third power. And this is I to the fourth power. And I said that I is the same thing as the square root of -1. I squared, well, we just discovered is -1. I cubed, well, that's the same thing as I times I squared. But I squared is -1, so it's just I times -1, which means it's negative I. Do you guys remember that? I'm going to draw this up nice and big and laminate them for you guys. And then this last one, I to the fourth, well, that's I squared times I squared. But I squared is -1 times -1, which equals +1. A negative times a negative is a positive. Okay, so we kind of drew that circle because you guys were struggling understanding the video. So when you think of this, I'm going to break it up just so you can see what's happening really fast. This is really -1 times the square root of 2 times the square root of -1 times the square root of 3. Or it's I root 2 times I root 3. I don't know which way is best for your brain to think about it. The I root 2, I root 3, that's how I think of it as well. But it is less number. It's less symbols, right? But what can you do with the square root of 2 times the square root of 3? You can break 16 up as 8 times 2. So that means you can reconnect them, right? If you can break them up as a product, that means you can multiply them together. So what is 2 times 3? So the square root of 2 times the square root of 3 is the same thing as the square root of 6, right? It's the square root of 6. You're just multiplying those two numbers underneath the square root symbol. And I times I is I squared times the square root of 6. But what is I squared? It's -1 times the square root of 6, which equals just negative square root 6. So we're just going to pull the i's out. Are you guys okay with that? So I'm going to use parentheses so you can really see what's going on in this one. So I have a negative times I root 3, and then I have times I root 6. Does everybody see that? It's an I root 3, I root 6. I root 3, I root 6. So let's multiply the two square roots together and multiply the two i's together. Yeah, what is 3 and 6? Not 18. So this is the same thing as the square root of 18. And I times I is what? I squared, and we have a negative out front. All right. Can we break up the square root of 18, TJ? Can we write that any other way? Someone tap TJ. He needs to pick his head up. It is not nap time. Do you want to come and stand at the standing tables? Okay, then keep your head up. So, square root of 18 is the same thing as what? Is there a perfect square that lives inside of that? 9 and 2. So this is the square root of 18 is the same thing as the square root of 9 times the square root of 2. What is I squared the same thing as? -1. And we have a negative out front. But what is the square root of 9? So I have 3 times the square root of 2. And a -1 times 3 is just a negative with a negative out front. What does this negative out front do to that negative attached to the 3? It makes it a positive. So your answer is 3 times the square root of, oh, don't look at that. 3 times the square root of 2. 3 times the square root of 2. So I'm going to freeze the screen and I want you guys to do this next example. The numbers that are outside, you're going to multiply together. You're going to turn this into I something times I something. Okay. Just try it. The worst case scenario, you have to erase it or scribble it out and redo it. What happens when you take the 2 and the -3 and multiply them together? What do you get? -6. So you have -6 on the outside. And then what's another way to rewrite the square root of -5? Don't close your Chromebook. You're not paying attention to what you should do. What's another way to write the square root of -5? I root 5. Times, what's another way to write the square root of -10? I times the square root of 10. I times the square root of 10. So you have -6 times I square root of 5 times I square root of 10. But what is I times I? And what is 5 times 10? So you have -6 I squared times the square root of 50. -6 I squared times the square root of 50. No, that's not our final answer. Because what is I squared? So this is where we are, but I squared is -1. And the square root of 50 is the same thing as the square root of 25 times the square root of 2. So what is the square root of 25? So I have -6 times -1, which is +6, times 5, which is 30, square root of 2. And that is your final answer. What are you thinking, Aubrey?
I'm thinking it's going to take some practice.
Some brain power? Yeah, it's going to take some practice for sure. I try to when I break up a square root that has a negative on it, I do it in parentheses just like I did. I root 5 in a parenthesis, I root 10 in a parenthesis, just so I can see what's really happening. So let's talk about this next one. What is I squared? So this is just saying 3 times -1, which is -3. TJ, pick your head up or you're going to come and stand back by me. What is, this is saying when you have a negative in front of something, that's the same thing as multiplying by -1, right? So that's a negative times I squared, which is what? So what is -1 times -1? +1. Yeah. This is different because both things are being squared. 3i, the quantity squared, means 3i times 3i. So we multiply the two numbers. 3 times 3 is, and I times I is. But what is I squared? So that's the same thing as saying 9 times -1, which equals -9. What do you guys think about this? I mean, it's kind of cool when you think about it, right? Okay. So you love it? You are smart. So remember that we said when you take the square root of any number and you square it, what happens to the square root symbols? Look at that example. I have the square root of -7, the whole quantity. Marlena, pick your head up, please. The whole quantity is squared. So what is the square on the outside doing to the square root on the inside? It's canceling the square. Exponent is canceling out the square root because they're inverses of each other. Can I show you another way to write this? You guys learned this in Math 1. You learned this in Math 1. Does anyone remember how to write the square root of a number using an exponent? This is the same thing as -7 to the 1/2 power. And then you square it. You did. You learned rational. If you had me, you did. We absolutely talked about fraction exponents, right? The top number tells you what power is. The bottom number tells you the root. So it's a half, it's the second root. If it's cubed, it's the cube root of something. But what is 1/2 times 2? Because the rule says you multiply exponents together. A power to a power, you multiply exponents. What is half of 2? So that's the same thing as saying -7 to the first power, which is just -7. That's why that works. Because the square root and something squared are inverses of each other. I promise. Sir. Yes, the next one is going to just be -16. You can say that because you're 100% correct. You don't have to do all that. I was just trying to show you why it is what it is. Sometimes you guys just don't want to know. You don't want the show and tell part. You're just like, just tell me why it is. I'll believe it. I need the show and tell part. I need that part. Okay. So I want you guys to think back to Friday. Back to Friday, and I'm going to draw my little circle again. Hang on a second. So this is I to the first power. You don't? Yeah, I love this thing. This is how I learned it back in the day. Okay. So here's how I want you to remember that this works. Remember that I to the first power is just I. I squared is -1. I cubed is -I. And I to the fourth power is 1. Notice that across the circle, they're opposites from each other. Do you see that? You have a -1 on the right side of the circle, and you have a +1 on the left side. You have a positive I on the top and a negative I on the bottom. Notice how they're opposites, okay? So remember what this means. This is first, second, first power, second, third, fourth, and it just keeps repeating itself in this vicious circle, right? So this would be any multiple. This is the 8th power or the 12th power. They all end up. So I told you guys, you take the exponent and you divide it by 4. What is 22 divided by 4? Well, it's 5 remainder 2. And that remainder 2 is the same thing. This is remainder 1. This is remainder 2. This is remainder 3. So remainder 2 is what value? -1. Well, why does that really work? Because I to the 22nd power is the same thing as I to the 20th times I squared. I squared is -1 and I to the 20th is +1. Because I worked myself around the circle 5 times. 5 times 4 is 20. But I just think it's easier to divide by 4 than breaking it up. So take the remainder. Yeah, you could work yourself. You could just keep going around the circle until you get to 22, which is fine. But what about if that power on I is 2,786? You want to go around the circle that many times? Just divide by 4, right? Just divide it. Okay. So powers of I. Listen up. Listen up. So here's where this little circle thing is. So the square root of -1 is I. I squared is the square root of negative 1 times the square root of negative 1, which we know just now equals negative 1. I cubed, well, that's the same thing as saying I squared times I, but I squared is negative 1, so it gives me negative I. I'm trying to fit it all in there. It's going to stick out of the box a little bit. I apologize. And I to the 4th, well, that's the same thing as I squared times I squared, but I squared is negative 1 times negative 1, which equals positive 1, which is exactly what we have on that circle, which I have drawn up nicely. I just need to copy it downstairs on the color copier in the library, and I'm going to cut them up and have Carly laminate them for me at the end of the day. So you just have little cards. You can stick it to your notes, put it in your binder. I don't care where you put it. I just think it helps your brain process that. And I use the idea of R1, R2, and R3 in there as the remainders. And I also put 0.25, 0.5, and 0.75. Because if you do it on your calculator, you're going to get a decimal. And some of you guys just need that extra explanation of the decimal. Okay. So we're going to do that we're going to use that divide by 4 idea. So we're going to take the exponent and we're going to divide it by 4. And if you have a remainder of 0, that just means that it's divisible by 4. And I to the 4th power is 1. So this equals 1. Because I went around my circle 10 times. That's how I want you to think about that. Okay. I to the 35th. Well, if I take 35 and I divide that by 4, that's 32. I get a remainder of 3. I'm going to go around my circle 8 times, and then I'm going to end back up at I cubed. Well, I cubed is the same thing as negative I. Or I to the 17th, I take my exponent 17 and divide it by 4, and that gives me a remainder of 1, which is just I. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. This is where I lives. Not that I would ever encourage you to just keep going around in a circle. That's horrible. Your remainder. Yes. Remainder 1 is I to the 1st power. Remainder 2 is I to the 2nd power. Remainder 3, and on that thing that I drew out for you guys, I put remainder 1 equals 0.25. Because if you're dividing in the calculator, you're going to get a decimal, right? Okay. Next. We're almost done. Yeah, we are doing the next page. So now we're multiplying. Now we're doing some powers. I think this is still at the bottom of your page, isn't it? Yeah, this is when I turn my PDF into this OneNote. It does all kinds of crazy stuff. So 5 times 2 is what? 10. And I times I is I squared. And so what is I squared? So this is really the same thing as saying 10 times negative 1, which equals negative 10. For this next one, I have negative 3 times negative 7. Negative 3 times negative 7 is 21. I times I is, and I squared is, so this just equals negative 21. Is this making sense? Okay. This next one is not as straightforward because I have to square this whole quantity. So this is really 4i times negative 2i times negative 2i. So let's multiply all the coefficients. 4 times negative 2 times negative 2 equals what? It equals positive 16. Who said that? Good job, Charlie. I times I is I cubed. But what does I cubed equal? It equals negative I. So I have 16 times negative I, which is just negative 16i. I always move that negative out front because it's like negative 1, right? It's just like multiplying by a negative 1. So let's talk about A plus BI. A plus BI. I'm sorry, Aiden, I saw that you were still writing. So A plus BI, this is a complex number because you have a real part and you have an imaginary part. It keeps erasing as I write it. You have a real part and an imaginary part. The real part is the A. The imaginary part is the BI. Now, A and B are just integers typically, right? Those are just, for all intents and purposes, they're just integers. That's what we've been using them as. So the A and B are still real numbers, but B gets multiplied by the imaginary unit, which makes it imaginary. Okay. So you have a real part and an imaginary part. So when you think about combining like terms, because this first example is just that, this first example is an example of combining like terms. I know that I have to make sure that if I combine like terms, that means I have to combine real parts with real parts, imaginary parts with imaginary parts. So this is joined by addition. So I really am taking 8, which is real, plus 3. And then I'm adding 2i to 2i minus I, the imaginary part. I can combine these two together. 8 plus 3 is 11. And this 2i, TJ, minus I, remember there's a 1 in front of there. That's no different than 2x minus x. So what is 2i minus 1i? It's just I. So that's a complex number because you have a real part and an imaginary part. So these first two examples are just combining like terms. So again, we're going to combine like terms. So I'm going to take the 1 and I'm going to add it to the 7. What is 1 plus 7? 8. I'm going to take the positive 4i and the negative 9i. What does a positive 4 and a negative 9 give me? Negative 5i. Can you guys see that that's a positive 4? Right? Positive 4, negative 9 give me negative 5. That's combining like terms. First two examples. Real part, real parts, got to be added together. These next two examples are subtraction. And you know that when you subtract, you have to distribute the negative and then combine like terms. So I'm going to rewrite it, distributing the negative, because I feel like if you don't do that, you're going to mess yourself up. So I have 3 minus I. Negative times 10 is minus 10. A negative times a negative is plus I. Do you guys see how that works? You distribute that negative out front. So when I combine like terms, let's see. I have a positive 3 and a negative 10. What does that equal? Positive 3 and negative 10 equal negative 7. And I have a positive I and a negative I. What are those going to do? It's like positive x and negative x. They cancel out. It's all gone. So your final answer is just negative 7. So again, we're going to distribute the negative and then combine like terms. So I'm going to rewrite it. Negative 6 plus 7i minus 3 minus 2i. Let's see, I can combine my negative 6 and my negative 3, and I combine my positive 7i and my negative 2i. So negative 6 and negative 3 give me negative 9. Positive 7i and negative 2i give me positive 5i. Absolutely. So this next example is a number on the outside. You have a complex number on the outside and you're distributing it. So you're distributing the complex number. And then we're going to simplify. So let's see. I times 3 is 3i. And I times negative I, well, positive times a negative is a negative. And I times I is, it's just I squared, yeah. So I have 3i minus I squared. But what is I squared? So this is really 3i minus negative 1. Notice how I put I squared in a parenthesis when I turn it into negative 1, because what do you really end up with? 3i plus 1. Yeah, you end up with 3i plus 1. Now, when you write a complex number, you always want the real part first. So am I able to change the order of addition? Can't I just rewrite those as 1 plus 3i? Yes, because I want the real part first. So I'm going to freeze the screen, and I want you guys to try the next example. You're going to distribute that negative 4i to each term. A negative times a negative is a positive. So let's see, negative 4 times negative 2 is positive 8. So I should have positive 8i. A negative times a negative is a positive, plus 12i squared. What does I squared equal? So I really have negative 8i plus 12 times negative 1. 8i plus 12 times negative 1. And what is 12 times negative 1? It's negative 12. So that gives me 8i minus 12. But the real part has to come first. Negative 12 plus 8i. Negative 12 plus 8i. So what I want you to remember is that anytime you have an I to a power other than 1, it can be simplified, right? It can be simplified. You can break it down into something else. So what do you think we have to do here? This is really a binomial times a binomial. Any ideas? What does that say? FOIL. 4 times 2 is 8. And I'll draw this as a box in a second so you guys can see it that way as well. 4 times I is plus 4i. I times 2 is plus 2i. I times I is plus I squared. But What does this tell me to do? Yeah, what is 4i plus 2i? It's plus 6i. It's like 4x plus 6x. And what is I squared? It's negative 1. So I really have 8 plus 6i minus 1. What is 8 minus 1? 7 plus 6i. I'm going to draw this as a box for those of you that like the box instead of the foil. 4 and I, 2 and I. 4 times 2, 8. 4 times I, 4i. 2 times I, 2i. I times I squared. You can combine those terms in the middle, so you get 8 plus 6i. And then I always take my I squared out and write it out as it is what it is, which is negative 1. When I use the box, I take my I squared out and write it for what it is, which is a negative 1. 8 minus 1 is 7 plus 6i. So you can use that box if you like that method, right? I want you guys to do the next example. Do you want me to do this with a box or foil method? Or both? Both? Okay. So this is what you get when you do it that way. You end up with this negative 8 times negative 1, which is what? What is a negative 8 times a negative 1? It's a positive 8, right? So you get 30 plus 8, which is 38 plus 14i. Oh, yeah, it's 30. So put these in a parenthesis so you can see that you have negative 8 times negative 1, which makes that a positive. Okay? Negative 8 times negative 1 makes that positive 8. Nothing. This is not I squared. You're combining like terms. So that's 14 times. And your negative coming in is positive. 30 plus 14i plus 13. Okay. Yeah, 38 plus 14i. 8 is at the bottom of the notes. Are we done? Is that it? Is that all of them? Because I gave mine away. Yes.